Welcome to the Human Factors and Ergonomics Hub, a series of educational podcasts that showcase the connection between human capabilities and good work design, brought to you by the Human Factors and Ergonomics Society of Australia. Thanks for joining us again on the HFE Hub. My name is Sharon Todd, and today I'm chatting with Chris Fitzgerald. Chris is a passionate certified professional ergonomist whose career emphasis has been facilitating meaningful and durable improvement in the design of work. His original career was in prosthetics and orthotics, but after 5 years of working in a clinical environment, he transferred to ergonomics in occupational settings. His work has involved the measurement of human activity in the workplace, including quantifying force exertion in complex environments, the use of EMG to understand patterns of muscle activity, and the utilisation of the whole body system with using 17 movement sensors to define the physical requirements of work tasks. So I'm chatting with Chris Fitzgerald this morning, and it's a pleasure to have you on board. Thank you for joining me. Your journey into human factors and ergonomics is an interesting one. Maybe you could tell us about that.
Yep. So basically my original background, career background was in prosthetics and orthotics. So very much good clinical skills, good biomechanics, anatomical skills. But I think the core skill was, someone hops in to your clinical room and your job's to help them be able to. So it's always been very applied. So I think I did that for 5 years, but I didn't particularly enjoy, the single location aspects of clinical work. And I travelled for a year, and then I came back, and all the legislations in Australia had changed from draconian legislation to, Robin's principles based. So that created opportunities. So, I moved in to do some occupational rehab, and then there was an postgrad ergonomics course in Melbourne, which is quite popular, mainly run by Owen Evans and Wendy McDonald. And so I sort of tagged into that, and then basically sort of converted to ergonomics approach. In the occupational rehab, that was, the practicality of more looking at return to work. But I started my own business in, the early 90s, and after about 5 years of occ rehab, I was able to focus on pretty much preventative ergonomics, and because I was self-employed and continue to be self-employed, I've been able to apply my own methods, I guess. You've got to survive commercially, you've got to pay the bills, but I've been able to adopt what I thought was a sort of worthwhile approach to projects. So that's a lot. So relative to that, and that's my approach has always been quite analytical, and maybe in that prosthetics background, but also being trying to quantify and in the quantification of work, whether it's the timeliness of work. In fact, what I learned, and I continue, a lot of organisations don't understand what their people do. They say we know this, or we actually here's our goal outcome, but necessarily on what they do. So often benefit of the external sort of perspective is you can ask the dumb questions, and why do you do it that way? And sometimes work can be quite straightforward, but my work's always been quite analytical, and I've always tried to quantify and then using that as a way of engaging with people and then facilitating a process of change. I'm saying, well, I've got this data that says this, it's throwing data. What do you think of that? And also gives you baseline information that if you can trial or quote an alternative way of doing it, you can always remeasure. So it gives you some capacity to evaluate, whether that's sufficient based on, but also quantification. So that's the focus of my. And as we started this about you're heading off to IAA, a lucky thing. You go to the IAA congresses for about 6 in a row, and there were some sort of very pivotal people that I met. I met Tom Waters in Tampere. So Tom was responsible for the revised NIOSH lifting equation, and we were staying in the same hotel, and he'd have breakfast, and he was just a very generous man. And, I was just a little dog spotty ergonomist from Australia. And he was fabulous. And he actually gave me a chart, and he said, look, Chris, this is how I perceive, physical work demands. And he goes, we've got, high frequency, which I use sort of physiological ways of looking at it, and low frequency, high force exertion. We're looking at biomechanics. And he said, this space in the middle, he said, we found the psychophysical stuff, originated by Snook to be really helpful. And he really, he gave me a construct that I've retained and kept using over the years. And that was really fortunate. So it sort of gave me it helped my natural approach in terms of giving it sort of a way of, well, what do I engage? Because you can talk about quantification of work demands, whether it's, looking at ranges of movement or force exertion, all those sort of physical elements. But in a sense, the problem with ergonomics is we don't have much in the way of a referential data set in terms of what are acceptable limits. And so that's the problem. So a lot of my work has been, not only quantifying, but also then engaging with people and organisations to then try and sort of say, well, we don't have a point of reference here, unless something's extreme, of course. But, so if we improve this and we remeasure it, and is that sufficient? You know what I mean? So it becomes so it's not just a one-off approach to say, oh, well, I'm the expert and I'm going to fix your problem. So look, this is what your data says, and let's have a look. So I good example of that is I reviewed a front loader for a large distribution centre. So it was a Toyota product, so there's no secret about that. And it was displacing. So Toyota, essentially it's European designed, but it has a sort of like a handlebars of a bike and like a front tiller. And whereas the traditional one was you're obliquely positioned and you're winding to steer. So there was made good sense. So we actually quantified. I used movement sensors to quantify the difference of those things. But then I then correlated my movement sensor results with the body height, range and gender of my participants. And we're able to sort of demonstrate really good rationale as to not only this was good design, but we were able to then create ways of optimising the use of that design to further improve the work. And part of that was the analysis was that there was a bias in some of the data for the shorter people. And so we looked at that, and because, most things are designed to favour men, there was people in the shorter height range, they were disadvantaged by the height relationship between the steering wheel and the floor. So we had to come up with a floor raising device, which was quite complex because it had a sort of dead person switch on the foot pedal. So, but in a sense, it was that was sponsored by Toyota, and I was able to say, look, we've got data that says this is a good design, but not quite right. And so, and in fairness to them, they came back and redesigned it. And the process, and this is a good example of I've talked about engagement with people. We then had a bunch of very angry men who didn't want to let go of their old methods, their old sort of forklift or loading devices. Sorry, I thought I'd turn my sound off. And I met with that angry men, a group of angry men, about 30 of them, so I was well and truly outnumbered. And I said, look, here's the data. I said, so, yep, I understand your concerns, but the data and our experience says this is at least worthwhile you participating in the trial. So I didn't sort of bang my fist. I just sort of gave them rationale. And it was hugely successful. And that's been the story in a lot of work that I've done. So we did some work in an alternative way of deploying fire hose for rural firefighting, so wildfire and bushfire. And rather than dragging out a hose full of water, which we could quantify the measurements of that, and we looked at a way of dragging out an empty hose and then charging it with water. and we actually ran a study. So it was quite a complex study. We did some physiological measurement. We got people to swallow temperature pills, and we had all sorts of physiological measures. We actually diagnosed someone with arrhythmia, so we would send them straight off to hospital. And we tested about 10 people over 2 days, and we sort of, comparing the different methods of deploying hose over a set distance and then charging it and then aiming it. So we got really good data, again, using movement sensors, using dorsal-V movement sensors, which is back and shoulder. And the results were phenomenal. So our most efficient physically and time-wise, so most efficient movements and time-based performance of the task was a firefighter who had his 75th birthday on the day of his assessment. And so, it was just fantastic. So, and so we were able to then use that, and we could, you could get there in at least sort of half the time and deploy 4 times the amount of water, which is also, gets in more into the sort of operational requirements. So I was getting back to the reason I'm telling this story is that, there was chatter around, and with the Country Fire Authority, they'll build a demonstration vehicle, and then they'll drive that around the state, and people have a chance to, have a look and test it and give their feedback. And so the pre-roadshow chatter was, they're destroying firefighting, and all that sort of palaver. And at the end of it, they were saying, "Why wasn't this done 10 years ago?" It's fantastic, And I think they're good examples of saying, because I'm a bit of a techie, nerdy person, but in a sense, it's not just about the data; it's how you use that data to engage in an organisation. And essentially, your role is an agent of change. If in fact the data says change is a good idea, and it doesn't always necessarily indicate that. So there's some good sort of anecdotes about, I guess, that reflects my practice. Yeah.
So your practice has been participative and engaging others, and you referred to a construct that was given to you that you've used in work. Networking. Maybe just talk about the construct.
Well, it's interesting because I at some point I thought I better do my master's because my post, it was just a postgraduate diploma in ergonomics a long time ago. So, and because I've been self-employed most of my life, and I had a young family, I'd started my master's, but I was never able to finish the major sort of project part of it. But I did, as part of that, have great fortune to spend a lot of time with Owen Evans and Wendy McDonald, and they were my sort of they were the 2 people running the course, and Owen was my direct supervisor. And I was doing a lot of work in the meat industry at that time. So I was doing these massive task analyses. And again, a lot of, in terms of that quantification, I've done a lot of work in industries that are traditionally consider their work unpredictable. And then I've sort of, I guess, just applied my approach to try and sway that view. In fact, it's a lot more predictable. It's just there's more range of what is within the options of predictability. So, and I think sometimes organisations saying, it's unpredictable, and that's why we employ men, and, that sort of unacceptable approach now, and at best lazy approach previously. It's just not tolerable. So being able to say, well, we've got a whole, population of adults that need to do, or, want to do this work or should be able to do this work. So a lot of that has been sort of quite, technical task analysis stuff. And it was Wendy that actually said that. She sort of said, well, the way I was communicating, the project that I was trying to get together to finish my master's, which I didn't. We would then, that she introduced this idea of having a construct, and so part of that construct was the information that Tom Waters gave me in terms of understanding physical demands, and that was one of my biggest learnings from Owen, is that because a lot of ergonomics practice in occupations has been under the auspice of the legislation and the regulations and the codes of practice and the guidelines, a lot of ergonomics work is talked about in terms of risk. And Owen was fantastic. Owen said, well, we can actually be confident. We say we can quantify the physical work demands, he said, quantifying the risk is another thing, and he's 100% right. So even then, I'm aware you do legal work and I do some legal work as well, and I'm very, very clear in my distinction, saying, well, I'm just doing something about trolley pushing now, and I've gone back to the psychophysical data, and just trying to produce evidence to shine light on the case. And I'll say these are the physical demands, and then I'll separately talk about the perceptions of risk or the assessment of risk. And I think it's important. So that's been part of my mental construct, and that's been the work through Owen and Wendy. The stuff that Tom produced, I would often use that in training. In terms of, particularly people with a safety role, trying to give them some way of, sort of just perceiving physical work demands, that, it's just not just, it's those variables, but, the stuff that Tom provided was sort of, had substantially influenced by duration and frequency and force exertion. And again, when the IAA was in Melbourne those few years ago, I was sitting next to Richard Sutherland, and Richard's a fantastic ergonomist, and Helen Moody from South Australia. So, this sort of collegiate sort of approach from everyone. And we saw a presentation from Aaron Garg, and he was sort of, weighing, from a research point of view, if you can affect force and you can affect sort of, posture and movements, which one are you going to go for? He sort of presented that, and he said, well, I'm going to err on the side of force, but he said it's line ball. And just hearing those, and I know there's research behind that, but hearing as a summary of that just helps affirm your own approach to saying, okay, force is important, and with force for the fireworks. So there's a fantastic practitioner, Eric St. Martin's, provides sort of force measurement sort of technology out of South Australia, and Eric's been fantastic. So I got excited. So I used to in firework, I'd have a computer with a force gauge, McMesson force gauge, wirelessly connected. So I'd teach the participant how to apply the force to make sure that our data was clean and representative. Then I would run alongside them, with my notebook computer, and I was saying, Eric, look, getting good data, but this is I'm a safety guy, and I really need to practice what I'm preaching here. So he actually created a Bluetooth connection for me between my force gauge and my computer, so I could park the computer halfway and go, off you go, and then I'd have continuous force data over time. It was just fantastic, and so that was sort of part of my construct. So I was able to then use that as a standard, just as commonly as I would a measuring tape. And I was able to do some pretty funky stuff. So I'd sort of, in the meat industry, and hopefully people aren't too offended, I won't get too descriptive, but clearing the back, pulling the skin off the back of a sheep. We were able to compare that just before Easter in Melbourne, which means that Greek Easter means they leave the head on, which is a bit gross, but we were able to measure that. And, we were getting sort of peak forces up around 80, 90 kilos as an initiating force to then sort of move that. And then once you present that data, it's just so compelling. So rather than say, oh, we think we've got a problem, Houston, you have a problem and you need to fix this. So we need to get creative about how to do that. And then, in fact, I did that. I did a lot of work and still do, up at Gundagai Meat Processors. They sort of big lamb producer, and they're family-owned business. A couple of brothers who were butchers who built their business up, and nice people to work with. When you're working there, in the old days, not so very much corporatised now, but you'd be doing your work on the boardroom. And you've got all the owners there, and they were quite engaging. And so when I presented this sort of data to them, they said, "All right, okay." So they bought their capital expenditure early by a couple of years. They said, "Well, we can't wait to do this." I said, "Well, that's pretty much right." And so, do you know what I mean? So it's not trying to be too nerdy, but trying to use some way of getting people to understand what work is occurring, the potential effect on their workers, and not even being able to quantify the value, but saying, "Look, this is worth doing." And even with Gundagai, I love that work. I love the irony about working in abattoirs is that there can be a confronting environment, but they're usually beautiful settings. They're out in the bush somewhere. And so, you drive 10 minutes out of town and it's anyway, so that's the case there. So I'm sort of rambling a little bit, but I'll get back. So we have a question.
We have a question, Houston. We had a problem. I need to ask the solution to the problem. What did you do about the sheepskin?
Yeah, so in a sense, so the technology at the same time was emerging. So they now have a way of they'll clear the back. Don't want to be too descriptive with knives. And then they used to sort of punch down to clear it. They now have 2 successive machines to do that. So they converted that to human-controlled but mechanical. Well, in fact, the first one's human-controlled that does that. The second one, it creates a way of a device holding that and then completely mechanically pulling it away. And the issue with it's interesting. So the issue with that, those designs can always, we do that, but they have to work 99.9% of the time. There was a Y cutter, so there was this sort of robotic way of cutting the skin in anticipation of further work, and it was a great concept that's in lambs, and but it only worked about 92% of the time. And so what are you going to do? So you've got someone standing next to the machine to catch the 8%. It's sort of, not okay. And what it does, it sort of, turns people off, well, this doesn't really work. You have to be careful in terms of introducing change, organisation, maximise its chance of success. And you really want to deliver a benefit as much as you can. And look, the role of the ergonomist, as you will well know, you try and provide information. You try and get a seat at the table if you can, but often when there's millions of dollars being spent, you don't necessarily get to follow it all the way through. So I've been trying to make my information compelling enough that it gets enough momentum to get them over the line and they introduce that change. So I'll talk about sensing technology for a sec, if that's okay. So getting back to my second IO experience was in, I think, the early 2000s in San Diego. Again, fabulous meeting. And I went to 2 pre-Congress workshops, and one was with Bill Maris, where he demonstrated his lumbar motion monitor. And the other one was from the US military. They did a hierarchical task analysis workshop again, and that helped my construct. So they said, okay, well, we've got all these tasks here, and that's the way we've designed our vehicle or our way of doing whatever we need to do as a military organisation. But here's what's really happening, And so they say, well, we need to, whilst this is what we want and planned for, this is what we actually know is occurring. So we need to reconcile the two. And that was just, for me, that was just a light bulb moment because, I was interested in, task analysis as a way of defining work. But anyway, so just we're talking about construct. That helped me understand that. So, in terms of I have to validate what people are actually doing, not necessarily what the system intends or the process intends. And again, that just sort of becomes another sort of, plate in your armour, I guess, or whatever sort of, whilst we're talking military terms. But Bill Maris's stuff, and it was great. It was a massive workshop of 4 people and Bill, and we had him for a whole day, and he had the lumbar motion monitor, which was this massive sort of structure that you'd wear on your back. So very much a lab-based device, and he was able to sort of quantify shear forces and direction and quantify it. It was just phenomenal. And I said, well, this is phenomenal, and this fits my sort of desire to quantify, but I really can't put this on the back of a paramedic or a firefighter. So I figured that eventually, using Moore's law, every 5 years, it gets half as expensive and 4 times as efficient, whatever that is. So I knew eventually something would arrive. And in Victoria, there's a company called Dorset V, and one of the directors, Andrew Ronke, presented at one of our, I think, knowledge through sharing, I think, whatever the events were in Victoria. And Andrew presented this, and I went literally and bashed his door down the next day. So I spent a year working with them, which wasn't financially viable for me, but I helped them transfer the clinical tool into the occupational space. And we ended up doing work in mines up in the northwest, and putting them on drivers for 12-hour shifts overnight, and it's just phenomenal work. And it was just bang, you know. So in fact, our work in the one of the mines, again, we were looking at seating posture, and we could actually quantify, you know, the lumbar curve. That was part of the dorsal V sort of gig, really, and there was just minimal variance in the data. So you had this sort of, you know, normal distribution like this, and the only time they varied it was when they went to the toilet, you know, which is hardly. And in a sense, part of my analysis of that was saying, okay, well, this is all really good, and if you looked at the approach for you know, trying to minimise risk, you know, whilst people are still driving, and now you've got more sort of remote driving, but I put my hand up and said, well, what about basic seat design and seat setup? So if you're going to be in that position, you know, don't we want the most optimal position for the person? Do you know what I mean? So, and there was no attention or insufficient attention being drawn to the, you know, just a fundamental. And so anyway, so that was good. And then so back to the avatar. I know where I'm going here is, again, back to Gundagai. And I did some work with just HSRs, health and safety reps across, you know, all parts of the process. I won't get too descriptive. And so we put sensors on, and so we go and get data. And so, you know, if they're, you know, grabbing something, if someone's sort of putting something on a table and then the next person has to grab it, they might reach across. So I say, well, if you actually just put that a little bit further, it's not really any more effort for you, but it's going to help that person out. So we would actually quantify what that meant in terms of, you know, the subtle impact on posture, movement, if needed, force exertion. And then I mentored those people for 3 months. So I'd go back once a month, and then they were sending me, I was, Chris, if we do this, you know, rather than doing 14,000 repetitions a day, we can get it down to 8,000. I'm saying perfect. And so that's what I'm saying in terms of using data to try and help people understand what's happening around them, and how sometimes simple change can be very effective. In terms of then, I'll just finish off the posture and movement stuff. So I then had good fortune to work on a project with RMIT University within the big build in Victoria. So Victoria's now broke because we've built lots of stuff. You know, we've got lots of tunnels and roads and all, you know, and the level crossing removal's been a worthwhile thing. So RMIT had this job looking at that, and they purchased a 17 sensor XSense gear. They're now called Movella. They've been sold a few times. And so I was able to expand the dorsal V work into that, and we just did some phenomenal work. And part of my arrangement with RMIT was being able to use that in other locations. So I've been able to put that on, you know, sheriff's offices and quantify what they're doing in their field work, because more and more people are working out of cars. So I'm able to use that to understand their work patterns, and we ended up then using that to design vans. And now their work, they've gone from sedans to, you know, utes with canopies on them, and so sort of that helped inform that process. And they'll get me back every now and then to help with the next steps. So it becomes this sort of, you know, that's, you know, almost a Kaizen approach where you're just continually improving. So with the movement stuff, and a lot of the quantification that I'll do in industry is that I'll contrive what I'm doing to but try and be very confident that what we've measured is representative, but I'm just kind of reduce my post hoc, you know, technical work. So I've done a lot in the TV industry. So I redesigned TV news gathering for ABC TV News, you know, a gazillion years ago. And I hung out with and essentially my job was part of a Federal Industrial Relations Commission. So they said, we need redesign. I'd been doing stuff for drama in TV down in Melbourne. So I got that gig. They thought it was a 2-day budget. It ended up being like an 80-day budget. Made the careers of some of those sort of mid-level executives, because we were able to sort of sufficiently improve the safety and the efficiency of what they're doing. They had to spend some money to do that. But I was hanging out with this journalist in Perth, and he did the precursor to Alan Kohler's. Alan Kohler was doing this sort of financial report, and that's where this came from. This guy's just fabulous. And so we'd be interviewing some mining executive, and he'd say, you know how you said X and then you said Y? Do you mind just putting them together in a single sort of, and so he was doing his sub-editing on site. So he wasn't changing what they were saying. I thought, oh, this is smart. And this guy, he was very efficient and delivered. So I learned from that. Yeah. And so with the technology for measuring what people do, I devised a system saying, well, I've got my task analysis, and because there's an element of repeatability in those workplaces, and then at the end of the task, I just say this is a non-task. So in a sense, I could isolate that data. So I had to come up with sort of creative ways, and so all of a sudden, it wasn't just about postures and movements. It's about all of a sudden you've got what you've done is you've standardized your data relative to work performance across your individuals. It's fantastic. And so I was finding the variance in my data was attributed to the variance in the work, not noise. It could be someone's posture movement or their technique, but you were capturing that in the data as opposed to some other sort of something else that disrupted that. And so I found that quite helpful. And it was also, again, helpful for organisations to understand, okay, well, we've got these 5 steps. So for example, I did some work at orange harvesting up at Renmark, use this technology. Oh, Chris, we've got a problem picking. I said, oh, let's have a look. Let's get some data. So got some data. And then I said, oh, look, I don't think you've got a problem picking. I said, what you've got a problem is delivering. So as soon as you pick that orange, all of your time inefficiency, not all of your risk, but most of your risk is getting that orange into that bin over there. And I said, you've got a delivery problem. Yeah, seriously. And so look, and so rather than say, oh, we've got a picking problem, that's where all the attention goes. If you can sort of try and help, so well, you've got a delivery problem, here's the data to support that. And, it may not be what you want to hear, but in a sense, there's strong evidence to say, this is your problem, and you're better off investing in that pathway to develop your solution. So,
what was the solution to the delivery problem after you have picked the orange?
Well, it's interesting. So, as it happens, a company in California was starting to develop that. And then I advised, and I'm not sure what the ultimate result was there, but they did then say, oh, well, these people doing that, and said, fantastic, why don't you support them do that? Because I think that's the pathway. But then if you look at other, fruit or vegetable harvesting, I was involved in some looking at the Reuben industry, so looking at berries down in mostly Tasmania, but not exclusively. And they'll use these they call them burrows. So it's an autonomous vehicle. It's just a tray with 4 wheels, and they'll pick and do that, and then that goes onto the burrow, and then the burrow will go out to a central sort of collection area, and then it'll come back. And so you're getting more of those sort of jumps in sort of technological sort of support. But yeah, and look, part of them were for the orange industries. To do that, then they would need to grow. So rather than grow their trees as a tree, they really should be trellising them. And even if you look at viticulture, if you look at the wine industry, I've done a lot of work in that. And if you look at the height range that they set their vines at, that's the biggest influence on particularly the people doing the sort of the cutting the canes. And that's very, very demanding work. But you've got a choice, but that choice needs to be informed by information. So, what's a good height range for setting a trellising for wine and grapes. But I will. So they're good examples of the practicality of using movement sensors. And with movement sensors, I think eventually they'll be worn as prophylactic devices. So we're entering this weird period now where I'm doing a lot with exoskeletons at the moment, and I've discovered some really sort of quite funky devices. But that's also occurring at the same time we're trying to reduce our use of humans to do work. So, I don't know, I assume at some point humans still doing manual work will be doing it because they can't technologically replace those people with that. I know that sounds horrible, but so those people will become higher value people. And so there'll be sort of a better maybe cost benefit or, a way of looking after them. And I think sensors will start to be used prophylactically. And, the Dorsivide devices can do that. They use that in their clinical setting. So someone's adopted a certain posture, it goes above threshold, could be a duration, it'll give them an alarm, it'll vibrate or make a noise, and they'll sort of change their posture. So I think you'll, you know what I mean? I think there's all these. I think the future over the next 5 or 10 years is going to be quite interesting as human supportive devices get more clever, and in a sense, some of these sensing devices are used more as biofeedback device. Yeah. Now, I found this. Sorry,
let's chat about biofeedback for a second, because I wasn't aware that that device was doing that. So just let's talk about that for a second. Yeah, so
I haven't sort of used the Dorsivide technology. I do track for about 10 years, but I know, that they've got that capability. So, so whether you just put a sensor on the shoulder and it was to do, or you put the sensor where you need to be sensing information, and in a sense, because it's digital, you can create some sort of algorithms around, it's just Boolean type logic. If this, then that. If this for so long, then I'll buzz you, or and even I was with the ambulance stuff, and I'll get onto that in a sec. But I did a lot of work in ambulance design in the States for about 8 years. I was head of ergonomics for a not-for-profit based in New York, and we were like corporate activists. We were activizing better design of ambulance. So the North Americans hadn't really, they got to the 70s and they sort of patted themselves on the back and then sort of walked away, whereas the Australians and the Europeans kept going. And also we had regulation to support that. And they're quite a fragmented industry in America. There's like, 50,000 ambulance service. It's all fragmented. It's local. Yeah, so it's at a local government authority, and you'll have a fire service and the fire chief's elected. And then, often they'll do EMS, bring emergency response work, and then you'll have a small fire service. So it's just very fragmented, whereas in Australia, we have the 2 biggest ambulance services in the world, and probably the 4, Victoria, New South Wales, Queensland and South Australia. They're single service in terms of their emergency service response. So they're quite huge. And I've just finished helping Ambulance Victoria looking at trying to get them to modernise their way of doing patient records. And, I think they've got a workforce down here about 5,500 personnel, which is massive. And they're 50% female, so, or more.
Well, I was really interested in the work that you were doing. So with ambulance, so records is one. Were you doing anything to do with patient handling?
Yeah, absolutely. So it's one of my, I talked about converting, I had in my business, I was doing a lot of OC rehab, and then I was able to sort of focus on preventative ergonomics. And the first big sort of involvements were with Country Fire Authority, and then I ended up developing vehicle design guidelines. So both dimensional and performance-based criteria. That's like 20 years old. But in fact, it's now about to be adopted by the sort of nationally, it's like a de facto standard now. So it's been sort of guiding that, and it's much more positively inclusive of shorter, weaker people, and that's a whole other area. But in a sense, it's one of the benefits of sort of being around for a while, is you get to see that work through, and they're talking about legacy, trying to leave a legacy as you get towards the latter part of your career that's something I'm really proud of. And in terms of ambulance, so if you look at fire services, when I first started that work, 7% of volunteers were female. Now you'll probably get 35, maybe as much as 38%, not just female, but more culturally diverse in terms of volunteer firefighters. Career firefighters is a bit different, but. And then if you look at, from that time, the ambulance work, so we're talking about the early 2000s, it was men are men, and, big tough and to be a paramedic, but, that's not the case. So it's now sort of at least 50-50, female, male sort of participation. And so there was one sort of to demonstrate the benefit of regulation. So in, I think, the late 90s, there was a Australian sort of standard or guideline, I forget the term, but that said there's 2 key principles for ambulance design. One is that occupants need to be forward, seated occupants need to be forward or rearward facing in terms of impact. So then you're going to be most protected by a lapsed, 3-point seatbelt. And also you need to restrain objects. So in a forward G crash, even at low Bs at like 60 or 70 K, that the forward impact needs to restrain an item to 20 Gs. So a 1 kilo item in a forward impact has a 20 kilo weight, essentially. So something that's innocuous becomes a missile. And so we then use those as basic principles. And then really it was an ergonomics approach after that. How do we achieve this and get creative? So some of the examples of that was I was involved in designing a newborn emergency transport ambulance for sick babies. So baby might be born at a hospital and there's sick neonates, so you got to chuff them off to a specialist hospital to help them. So they have this essentially it was a humidity crib on the back of a stretcher. And then, so the stretcher's long ways in the back of the vehicle, and then you'd have a doctor and then you'd have a nurse, and their orientation. So we can't sit sideways because we can't protect people, got to be forward or rearward. But the baby, so I sort of configured it so the nurse could slide forward and do the obs through the portal, through the side of the humidity crib. But occasionally if the baby gets really sick, the doctor might need to do CPR or whatever, and they would turn sideways. So we got the capacity to turn that seat sideways configured to the on-off switch of the vehicle. So you could only turn that seat sideways when it was switched to off or accessory. Now that doesn't really stop them. They might just unbuckle and sit sideways. That's I can't control that behaviour. But in terms of an inherent design that says we're going to commit to our designs so much that we're not going to let you do that during movement, is important. And it's interesting in the state. So as part of that work, so I did a lot of that work here. We designed, there was a 5-year project to build a bariatric vehicle here, which ended up taking 3 months. The last 3 months was a sort of rush to finish. So we, it was participative. We had, a big team of representative firefighters, the vehicle people. We had the truck. We just built cardboard stuff in the back of the ambulance. We didn't have bariatric, so we just used 2 people to try and get volume. So, excuse me, that created, and so we got a good design. Design's always improved, but we sort of hit pretty close to the mark. And then part of that was the introduction of some specialist handling equipment, things like the hover mat. So we knew we could only use the hover mat if we had a firm surface underneath. So we'd create our own ground surface. So we'd actually have, like your auntie would put, plastic covering on her hallway carpet because, you never want to get it dirty. So we'd have that. So we could create our own ground surface for about, 2 lots. So, about 10 metres at a time. So you could just leapfrog it if you needed to. And we came up with some very, very creative ways of not having to lift and carry. So we moved to that principle of slide and drag, and that became the basis for the bariatric activity. And we did some phenomenal stuff. We'd package people up on a spine board and we'd lower them down steps and go over rockeries. So it was really quite a fertile period in terms of exploring how we were going to tackle person handling in that environment. And then that made its way into the sort of conventional ambulance paramedic repertoire. So things like the Mangarel, air technology. If you want to push something up, you either pull it up from above or push it up from below. So, they were able to sort of, get creative. And now Ambulance Victoria, so this is, 23 or 4 years later, dedicated manual handling coordinators. So, and I work with them now. So they're just fantastic. So their gig is they'll show up at a scene and they'll advise and observe. They're competent paramedics and highly competent paramedics, but they purely advise and yep. So that it's pretty amazing. And South Australia had that model, and we picked that up from them. And then I think it changed in South Australia, and I think they might be going back to it. But it really is quite a fantastic model. So it's not, again, you're talking about trying to influence people's behaviour in an unpredictable setting and stressful. You're trying to save a life. you've got someone basically out there watching your back, then they'll write that up and they'll advise it, and hopefully it's an ongoing learning process. But the work I did in the States was really quite interesting. So it was from 2006 to 2008. So I did this ergonomics, and it was started by a Melbourne doctor, Nadine Levick. She was a paediatric emergency specialist, and she's Orthodox Jewish, so she sort of chose to live in New York, and she was between jobs, and she started this foundation, and we would go to trade displays in America, and we'd fly a bunch of people over to Germans. The Germans do sort of trade sort of activities really well. One year we flew 25 people from America. Half of them had to get their passports. They'd never been out of the country. And so we would put them into the trade event in Europe to show them, here's the current design and the current direction of design, as opposed to just, presenting something on a webinar or, a paper or something like that. We were trying to give them an experience. And it's interesting talking about technology. So that was early on in some of the vehicle technology. And I was with a guy who ran a service in Dallas, and Chuck, and we were sort of hanging out, and he kept getting these pager messages. Oh, what's going on? He said, well, we've got this technology now in our vehicles that they give us three things: speed, torque through corners, and whether someone's wearing their seatbelt. And so he was getting live updates about non-compliance for that. And then he showed me some data, and they put this technology in, and a lot of that technology and more is available in vehicles now. Some vehicles are calling the ambulance before you have the crash because they know you're about to have a terrible crash. And he said they put this technology in, they measured, and they got hundreds of thousands of misdemeanors over a period. They had a period saying, well, we've got this technology now and we're keeping an eye on you. And so there was this introductory period, and it dropped off a little bit, and then they're a little bit punitive, but they brought in a 3 strikes you're out policy, and you had hundreds of thousands of misdemeanors come down to maybe several hundred. I've never seen data fall off a cliff. And what is that? That's a feedback mechanism. Regardless of I'm not massively in favour of a punitive approach, but that's part of what they adopted. And in fairness, it's road vehicles. So if you're in an ambulance, so travelling in an ambulance is a public safety problem in America, or it has been. So you're 35 times more likely to die as a result of an ambulance crash in America than you are in Australia. And a high proportion of those people that die are either the patient or people in other vehicles. And so that's sort of the scenario over there. And so Nadine was able to sort of coalesce a bunch of nerdy people like me. So I sort of got to meet some phenomenal and work with some phenomenal people. So there's a guy called Gene Likianov, and Gene was the lead engineer that developed electronic stability control. And so he was, we'd share a room often, and, he's brain the size of a small planet. And then there's another colleague from Norway, Ronald Rolfsen, and Ronald, builds ambulances, and because they're highly consultative, they very much a Kaizen approach. They're improving every time. So I've sort of then had this sort of through Ronald this involvement with the Oslo ambulance service, and they've probably got the best ambulances in the world. And if you then look at that, yes, that's an ergonomics relationship. So we in Germany, Ronald says, I need to build bariatric tracks. So, let's go and have a look. So we go and look at the existing vehicles, and I'd send him my stuff anyway. And I said, look, this is good, or, so we and then he'd just go and build it. And, he created this sort of, this rising tide effect in Europe, where as Eastern Europe opened up, he would use ambulance builders. But then they say, have you done the looming correctly? And have you done this? Oh, yes, we've done that. Said, fantastic. So he'd fly in, he'd unscrew the whole vehicle and check it all. And, well, you actually haven't done that. So, if you want to get paid for this contract for 20 ambulances, get your act together. And so he was very influential. And then more recently, Norwegian's government has donated 7 buses to Ukraine, and they're like trauma treatment. They're a whole range of sort of large vehicles that provide some sort of medical service, and so who are you going to give that job to? You're going to give it to Ronald, and he built and delivered his first bus within 4 months of that project, and he's now finished his 7 bus, and he and I are trying to work on some other type of prosthetics work based in Ukraine. So I guess my point is that an ergonomics approach, it can lift these people, and if you look at that there is, and he will have applied ergonomics work or perspective from what he learnt in ambulance to those sort of, in terms of access, egress, positioning of things. When we chat every few months. He's been to Australia a few times. I'm hoping to get to Norway within the next 12 months. Yeah, it becomes quite collegiate, but the influence that bears is quite phenomenal. And I know we're conscious of time. I'm going to finish with one story, if that's okay. Working, so years ago, the way we used to load stretchers, I quantified that. So I quantified the force to lift and load a stretcher, conservative patient weight, maybe 82, 83 kilos, very much underrepresenting. Then in the States, I was presenting at the inaugural EMS sort of foundation through the National Academies of Science in Washington, and so we had pre-conference workshops. So I presented that to the 2 key providers of stretchers, Furno and Stryker. And so I actually redid the study. A friend of mine ran a service up near Niagara Falls, so I went up and I quantified all that work. So all of my work looked as if it was in America, because I learned that if you don't do that, people go, oh, well, that's just in another country, and they dismiss it. But I was able to show all of their stuff, and I got the same results. And the head of Stryker came up to me and said, "Oh, Chris, we didn't know that." I said, "Well, you need to know that, Gary. This is the science, and people are dropping stretchers down in Florida and killing the patients. This is something you need to do." So they did. And then at the next German event I went to, I'd sort of walk by their stall, and they were demonstrating this sort of phenomenal stretcher technology that sort of self-loads. And so, and that's now what's been adopted, pretty much in Australia. And so I'm not claiming the work, but what I'm saying is that, it's an ergonomics influence, and, we can trace it back to that. And I think that's fantastic. And so that's, so I'm happy to sort of bail out at that point, Sharon. I know we've sort of got to finish on time here. So
I think it would be great, though, to ask what is next.
What is next? That's a good point. Survival. So the pandemic was very difficult. So I only just survived because I secured a big project in the meat industry. Otherwise, I may not be talking to you now. I thought I'd been forcibly retired. Ergonomics is about working with people, and that we weren't able to do that as effectively. And so I did this project I was asked to assess a couple of exoskeletons, and I had a look, and I said, look, this is becoming exponential, the development of these technologies. I said, why don't we do a world search, see what's around, see what's applicable, see what the needs of the meat industry are, and rather than being presented with a sales approach, let's get ahead of the salespeople and say, well, if you want to sell us something, this is what we need. This is what works for us. So they said yes, which is fantastic. So that was a big project, kept me alive over those few years. And then we're just about to, so we got about 20-something devices, and some of them are quite smart. One in particular is a glove, a powered glove, which sounds remarkable, but it has these sort of fine wires, like fishing wires. And it goes to a multi-core, and then it goes to, essentially it's like puppets. So these hooks in a device, and the AI, there's pressure sensors in the thumb and the palm and the fingers, and according to the pressure exerted against those, they'll sort of understand the nature of the gripping force. I'm running out of voice here. That and a few other technologies we're about to. So just using the AI in that technology reduces grip force by 15 to 18%. And so my project is, what's the configuration of the different fingers to try and get up that close to 30, 35%. It's an industry that can't attract and hold labour. We can reduce the force requirement, and there's still years off fully mechanising that type of industry. It's still going to be a lot of handwork. So the notion of this glove and what it can do, and if we can configure that, because again, it not only provides assistive, and there's an AI component, and I can reconfigure, how quickly, how much, how long. I can configure all that. And I would do that with meat workers. I'd say, what fingers do you think you're using most to grip a knife? This one, mate, these two. Oh, really? Okay. Which I'm not believing, because there's no mechanical advantage. You need leverage. And their little finger, the data says their little finger is used just as much as their index finger. And so in a sense, that's a learning. So, and so the good thing about these technologies, and this is what I was saying about talking about biofeedback before, is we get data. We're getting data sampled the whole time. And that particular data set is pitched against some quantified work, which I won't explain now, but there are sort of threshold values. So if we're within those thresholds, then it says, well, you're probably okay. So it's really expanding that body of work, and there's some other exoskeletons in terms of the practicality of it. So I've written the roadmap for the industry. The biggest challenge for the industry is how do we clean these things, because everything needs to be washed and sterilised at the end of the day. So you could have the best design in the world, it's just not going to work in the meat industry. It needs to be soft, washable, or disassemblable, and they're just vital. So I think there's that merging of people with machinery in occupational settings, and also interesting. So I think just trying to sort of modernise and so the stuff I've done for Ambulance Victoria recently, they do their patient records, and just because they can't use the time in ambulance because you can't sort of write and sit whilst they're in a moving ambulance. So I've been trying to point them towards combining AI and voice activation, selective voice activation, not continuous voice activation, but even for the navigational side of it. So they're looking at sort of raising a sort of big project and trying to get that sort of demonstration. And they're one of the few organisations in the world that can do that, because they're one of the biggest services in the world. And so you've got this sort of massive precedent setting. So I'm always trying to think of what's coming towards us and how can we run towards that and engage with it to get better outcomes within a workforce.
Don't forget the Human Factors and Ergonomics Society conference this year is being held in Brisbane between November 25 and 27. Our program is available on the HFESA website, being hfesa.au. Thanks for joining us at the Human Factors and Ergonomics Hub, brought to you by the Human Factors and Ergonomics Society of Australia, where human-centred design really matters. If you like this podcast, make us your favourite in your podcast app. We look forward to chatting with you next time.